Let's draw the Lewis structure of C2H4, which is ethene, or commonly known as ethylene. To accurately draw the Lewis structure of C2H4, follow these steps. Begin with a rough sketch. Depict the chemical bonds between the atoms. Identify and mark lone pairs on the atoms. Ensure that each carbon atom has a complete octet. Conclude by calculating formal charges, aiming for a stable Lewis structure with the least possible formal charges. Before constructing the preliminary sketch, we will begin by calculating the total number of valence electrons and then determine the central atom. The total valence electrons in C2H4 can be determined by summing the valence electrons of each atom. Each carbon, a member of group 14, contributes 4 valence electrons, while each hydrogen, a group 1 element, provides 1 valence electron. With 2 carbons and 4 hydrogen atoms in C2H4, the total valence electrons calculation is 4 for carbon multiplied by 2 plus 1 for hydrogen multiplied by 4, resulting in a total of 8 plus 4, which equals to 12 valence electrons for C2H4. When determining the central atom for C2H4, prioritize placing the element with the lower electronegativity at the center. While hydrogen is present in C2H4, considering it as the central atom is not valid, as the central atom typically forms bonds with at least 2 other atoms. Since hydrogen generally forms single bonds due to having only 1 valence electron, it is less suited for the central role. Therefore, in the case of C2H4, opt for either carbon as the central atom. Choosing the left carbon as the central atom, the rough sketch involves positioning 2 carbon atoms at the center with hydrogen atoms arranged on the outside. A single chemical bond is represented by 2 electrons. First, we will position 2 electrons between 2 carbon atoms to illustrate a chemical bond between them. Similarly, we will place 2 electrons on the left side to indicate the chemical bond between the left carbon and left hydrogen, and on the right side to indicate another chemical bond between the right carbon and the right hydrogen. We will repeat the same for the top hydrogen atoms, using 4 electrons to depict 2 chemical bonds. In total, we have utilized 10 electrons, leaving only 2 electrons unutilized out of the 12 total valence electrons. Lone pairs consist of electron pairs not used in chemical bonding, and each pair comprises 2 electrons. With only 2 electrons remaining, 1 electron pair can be formed and marked on the structure as a lone pair. It's also important to note that carbon is a period 2 element and cannot keep more than 8 electrons in its valence shell, while hydrogen, a period 1 element, cannot hold more than 2 electrons in its last shell. Another crucial consideration is to initiate the marking of lone pairs by starting with the outside atoms before moving on to the central atom. In C2H4, the 4 outside hydrogen atoms won't receive any lone pairs, as they can't hold more than 2 electrons. The right carbon is the outside atom, so we will mark 1 lone pair on it. For the central atom, left carbon, there is no lone pair to mark, as we had only 1 pair to indicate on the structure. For the 4 outside hydrogen atoms, the duet is complete, and for the right carbon atom, the octet is fulfilled. However, the central atom, left carbon, still doesn't satisfy the octet, so we will work on completing the octet for the central atom, left carbon. Once again, keep in mind that carbon is a period 2 element and cannot hold more than 8 electrons in its valence shell. The left carbon already possesses 6 valence electrons and requires 2 more to complete its octet. Therefore, we will convert 1 lone pair from the right carbon atom and transfer it to the left carbon atom to form a chemical bond. Now, it is evident that both carbon atoms form an octet and the 4 hydrogen atoms form a duet. Thus, both the octet rule and duet rule are satisfied. Now let's proceed further to check the formal charge to determine the stability of the structure. This is the formula we can use to calculate formal charges for the C2H4 Lewis structure. Formal charge equals valence electrons minus non-bonding electrons minus half times bonding electrons. Input the data and allocate the values to determine the formal charges for each corresponding atom. For each carbon atom, valence electrons are 4, non-bonding electrons are 0, and bonding electrons are 8. So the formal charge will be equal to 4 minus 0 minus half times 8, which equals to 0. For each hydrogen atom, valence electrons are 1, non-bonding electrons are 0, and bonding electrons are 2. So the formal charge will be equal to 1 minus 0 minus half times 2, which equals to again 0. The formal charges of both carbon and hydrogen atoms are mentioned, and it is evident that the current structure is stable, as formal charges on each atom are 0. Therefore, this structure is the preferable stable Lewis structure of C2H4. To represent a pair of bonding valence electrons, we can simply draw one horizontal line. First, draw 2 horizontal lines between the 2 carbon atoms, as there are 2 pairs of electrons between them. Then, draw 1 horizontal line between each carbon and hydrogen atom, signifying that there is a double bond between 2 carbon atoms, and each carbon is single bonded with 2 hydrogen atoms. So that's the Lewis structure for C2H4. If this explanation made sense, press the like button, share the video, and subscribe to the channel.